So with all the homework questions having been done, what I would like to do is spend time on is what I've been calling problem solving with the ChatGPT. So I think you saw when I did the optics demo a way of how people could use it dishonestly, and I'm so sure people don't need to be told how to cheat using something; they figured it out. So it's not like I need to do that demo. It's more of a kind of you know that I know kind of deal. But I think unlike websites like Check, I think a ChatGPT generative AI is so capable that you can actually use it for good instead of evil. You can actually use it to learn instead of cutting corners. Whereas I think websites like Check, I don't think their tutors ever teach you anything. They are so incentivized to just give you answers that yeah, I've yet to see a single person who could learn from Chat. But ChatGPT, I think as long as you decide that what you want to do is learn from the explanations that generative AI can provide, then I think you can actually learn from it. So let me do that demo. I'm gonna go into problem set 6 as a test student. I think I need to check a bunch of things, so let me do that. And then I'll do this demo that I've done a few times in this semester where I'm basically asking ChatGPT questions, but I'm also giving it instructions. Hey, I don't want the answer right away. I really want to be taught how to learn, I really want help learning this material so that I can do this question again in the required one-on-one meeting, which is some of you have done. More of you need to do it if you're trying to get an A or B. And that's yeah. And so and even though ChatGPT does come out, its a factory built bias is to just tell you the answers because that's what most of the human beings using it actually prefer. But you can just tell it that that isn't your preference. Then ChatGPT is smart enough, it's capable enough that it'll know that you want something different, and it's able to customize, tailor its approach to what you actually want. And that's, I think, the real benefit that that you couldn't have in a system that's not as smart as a current generation of generative AI. So let me bring up ChatGPT. Now, I got a warning message earlier today that I'm running out of O1 responses. So it's possible that today, as we are working through that, I will run out of O1 response. That's possible. If that happens, we'll deal with it. So I think once I get a warning, I usually have like 25 responses remaining. So I think that might be enough to like get me through half of this session. So if it runs out, then I can switch from O1 to, I don't know, 4.5. I did see I think O1 is better. And O3 mini, even though it's more recent, mini means it won't take any screenshots. And I do think when you're using ChatGPT as a tutor, the ability to paste in images and get have a ChatGPT provide a response based on that is, I think, almost indispensable. So I don't think I can switch to O3. So anyway, so let me give it a start. Maybe we won't run out of O1 responses today. So let's see here. So let me first start with a demo of how you shouldn't use ChatGPT. Again, this is a demonstration of just the bias of ChatGPT. That if we simply ask it a question, even without an instruction or a request to please help me cheat on my homework. I don't want to learn. I don't want to do anything. I'm lazy. So just give me the answer. I'll put in the answer and move on. Even if you don't tell ChatGPT that, it'll assume that's really your use case because that is really the typical thing humans use computers for. Avoid the work, be lazy. So it's been trained that humans are like that. Tell it that you are a different kind of human being. Tell it that, oops, I keep saying oops. Let me just say something different for variety. I can say, I can say oops in my head. Um, I'll say thank you, but I think I need something different. I'm preparing for a required one-on-one meeting with my instructor, and I need to be able to redo these questions. And from my experience, I know if I just receive the entire solution right away, I won't learn it, I won't remember it, and I'll have difficulty doing it again. Can you please help me learn by not giving me the answer right away, and maybe just helping me with the immediate next step if I appear stuck? Ask me for what I have done so far. That's really what asking you for what you've done so far is what a good tutor is supposed to ask. Instead of either assuming you don't know anything or assuming you know certain concepts that maybe are maybe not a lot of people have. A good tutor will first ask you, okay, show me what you have, and I'll help you get to the next step. So, here, I think wasn't substantive question anyway. That's why I was willing to burn it, but I just, you know, have this beginning of the session interaction. So let me get to a more substantive question. Now, I will tell you this with the modern physics. So there's a bit of a disconnect between level at which I would like to cover the material and level at which you see the material um, covered in the uh, covered in the lecture actually, and level at which you would be required to do the homework. Homework is in some sense a lot easier than the concepts in the lecture are, and it's a the real problem I'm working through is that hard to have an auto-graded question set that is substantive in modern physics like special relativity. So, one thing I could do is, here, what is V if V? What is gamma if V is this? And it's easy enough to calculate. So let me do it this way. I'm going to calculate the gamma here, which I easily can with a calculator. So let me write down the formula for gamma that I'll pretend that I looked up from somewhere. So the formula for gamma is defined in terms of V or beta. Here, since they gave us V, let's use V. Gamma is equal to 1 over square root of 1 minus V squared over C squared. Or 1 over square root of 1 minus this number in front squared. So let me do that. 1 divided by square root of, I have to be careful. Let me do parenthesis open, 1 minus the V over C, 0.1 squared, parenthesis close, and then square root. That way square root is applied correctly. Then say equals 1.005. And I'll do the same thing with the next number. 1 divided by 1 minus 0.9 squared, square rooted, is equal to 2.29. So what I do is, first start by saying, oh, I got the right answer. Wait, did I miss something? I might need the next digit. Yeah, right. Question did say calculate gamma correctly down to at least thousandth place. Yeah, it's because at some point. Although I think here I think it would have been fine. I would have been fine keeping only 3 sig figs, and like it accurately represents the accuracy of 0.9 C. So here, what I will say to ChatGPT is I will tell it that I got the right answer, but I'm not sure if there's anything deeper than just the formula that I looked up. So let's see if ChatGPT will give you more in-depth explanation. I'm actually curious because last year, modern physics is where it kind of started to struggle. So on the next question, at the right answer with the same formula, but I'm having trouble seeing point of the question is. And if ChatGPT is able to get a sense of this numerical value range, it might be telling me that the point is to develop number sets about relativistic velocities and gamma. Like going from zero point 0.1 to zero point 0.9 didn't quite nonopol, multiply gamma by a factor of 9, because it's not how they are related. Um, so I think that was the main point when I wrote in this question. Let's see. Can we go by playing numbers intended to show how the behaves? Yeah, number sense when you're well below. Yeah, so like 0.1 versus 0.01, gamma will be approximately 1. Um, yeah, and with this range, it's harder to see how much larger it is because at the moment, V increased by a factor of 9, but gamma only increased by a factor of 2.3. So in some sense, you might think, oh, it didn't increase a lot, maybe. Um, so how do you notice how quickly or slowly gamma grows with V and with near the speed of light? So let me kind of give it my misaligned understanding of what I was saying, so I'll say, okay, so I see V increasing by a factor of 9 while gamma only increases by a factor of 2.3. So is the lesson that gamma changes more slowly than V? And it should tell me, oh no, that's not what that means. Maybe even give me another example of 0.99C, which, is only increased by 10% from 0.9C, but gamma changes quite dramatically. Yeah, gamma doesn't just scale linearly with the V. Lesson is at low speed, yeah, stays. So it basically doesn't change at all. At low speeds, you shouldn't be using gamma unless you're going to subtract out one or keep a ton of significant figures. As you approach, gamma begins to blow up. Yeah, because C, V will be limited as C, like it will never exceed the C. Gamma increases without limit. Yeah, that's pretty good. So if I calculate for this, as I was saying, yeah, as I yeah, yeah, I 1 year ago, year and a half ago, 2 years ago, I didn't think ChatGPT could be trusted. I thought it would be wrong too often. Like I was worried that people would get wrong concept, wrong answers from ChatGPT. But what I have to say now is, yeah, this is perfect answer. That's what I was saying before I started the reading. So yeah, from 0.9C to 0.99C, gamma went it almost tripled. Yeah, almost tripled. Maybe a little over than tripled. So yeah, that's good number sense thing. Let me see if I can find a more substantive question where I can imagine someone being stuck, not just uh, wondering about. Uh, This seems easy enough. So from this, you can calculate gamma. Once you know gamma, you multiply to this to calculate the time dilation factor. Let me look for a more tricky question. This can be slightly more tricky. Um, so you could imagine you know how to get gamma. So let's say you write down gamma or the let me actually start with this. So you might have definition of gamma remembered. Yeah, write it properly. 1 divided by square root of 1 minus v squared over c squared. And if this is the only context in which you feel you know gamma, then you will feel here that you can't do this question. So let me ask this question from perspective of the student. Who's feeling that way, definition of gamma, which does not help you with this at all. So what ChatGPT should be telling you is that you should use a time dilation relationship to get gamma directly instead of trying to calculate it from V. So Okay, I have this question, and I don't think the gave us enough information. I need a V to calculate gamma, right? And again, ChatGPT, if it's working as well as I think it is, then it needs to kind of guide us to time dilation, because that's the information you are given. You are given the proper time, you are given the dilated time. So, question of okay, what's the relative velocity between the frame of neutron and the observer? So if we ahead of time to find gamma, it can work backwards. Ah, interesting. Yeah, longer than yeah. It's guiding you towards time dilation formula, which basically gives you gamma right away. It's a little bit over two. 2034 divided by 900. So you can solve for Lorentz vector gamma first. Oh, so let's get gamma first, and then I wonder if it'll give us the formula for the sorry. Wonder if it'll give us the formula for. I don't know. I wonder if it'll give us the formula for the V in terms of gamma. Because once you drive it, there's a format in which it's pretty easy to memorize. So let's calculate gamma first. Just the ratio 2034 divided by 900 comes straight from this relationship here, 2.26. So I'll say okay, I got gamma equals 2.26. What's next? Yeah, let me leave that there. So I wonder if it'll just give us the formula for V right away and have us plug numbers into formula. If it starts to do that, I think you need to be a little bit more wary, either in terms of not simply accepting the answer that it's giving you, or taking extra care time. So here it looks like it might be going through the right steps. So it's starting with the expression for gamma and imagining doing the algebra to solve for V over C. So yeah, take the reciprocal, square both sides, isolate V over C, and yeah, that looks right. And the formula I remember is the square root of, oh wait, did I? Yeah, yes. Formula I remember is the square root of 1 minus 1 over gamma squared. So, um, so yeah, I guess I can just do that. Let me just see if there's something more interesting to read out. Yeah, let me do that. So that's my gamma, and I need to, let's say, store this into buffer, and then 1 minus 1 divided by memory recall squared. Okay, that's gonna give us a V over C squared. So once I have answer to that, I need to take another square root, 0.897. Yeah, I think that's right. 0.897. So, compared to the other numbers we were looking at, this is not ultra relativistic. It's only 90% of the speed of light. When I think of situations that are ultra relativistic, I think about where the speed of basically you could almost approximate speed of the particle as the speed of light. It's like 0.9999 c. But the fact that it's not actually one, that is important, because that actually traveling at speed of light, it's something that only massless particles like photons can do, which is more of a later material. So, right, let's look for another question to work through. I really need to find a more substantive question. Let's see. Yeah, this is again kind of a formula to give you gamma and then calculate V from that. Relative liquids are to be less than 7%. Gamma. Oh, yeah, that's I think right. Relative velocity is so here I guess I don't think it makes sense for me to pretend that I don't know the answer, because it's basically this again. So I can actually do it on calculator. Where, all right, I'm just gonna do that again because it has that. Oh, I thought it did have the square root thing, but never mind. So for 1 over gamma, it's going to be 1 over 1.07. You square it. Let me put that into memory. Um, I'm not sure. It might have. I think it actually did it. Well, um, oops. No, I think I missed something. So let's see. 1 minus 1 over 1.07 squared is equal to that. I think I had it right. So this 1 minus 1 over that, yeah, that, and that is the v over c squared. Now, if I take the square root, then that should give me 0.356. So I think that's right, 0.356. What mistake was I gonna make? Um, that's what I'm confusing myself with. I was gonna try to make a mistake. Eh, Let me look for a substantive question, one that won't make me fall asleep. The thing is, I think all the questions in this set are easy. It's next week's material that I'm looking forward to. Um, let's see. No, this might be a slightly more substantive question, but let me look at question 10. Yeah, I think um, because a lot of these are just applying formulas like for beta. So in the lecture, I've given you this formula for beta. Beta is basically speed v, except when you don't want to deal with the speed of light as a numerical quantity. So how fast is the astronaut moving relative to Earth? Calculate the speed beta, correct at least to 10,000. Oh, I need to actually compute it. Oh, I think I know why. Because if you cut it off too early, you will basically get one, and you don't want that. So let me just first get from the gamma factor what the um, beta should be, I guess. So the in terms of gamma factor. Oh, let me ask you this. So I mean, ChatGPT gave this answer earlier, but let's say I'm just confused about beta. So I will ask. This question is about beta, and I'm not sure how to answer that with the information they gave along. Uh, Lorentz vector, distance, and um, so the mistake I was gonna make. So you are given the gamma. So let's say you could relate gamma to V, but let's pretend we don't know how to go from V to beta, which is super easy. As for beta, and they give Lorentz factor, distance 9 light years. They are for beta, and the info I have only goes directly to speed v, which isn't correct. But I can imagine someone thinking that the distinction between the two things. Let's see how ChatGPT handles that question. Yeah, just a symbol for ratio. Yeah, that's it. You've already found the way. Yeah, you don't need any. Yeah, that's great. That's exactly what you're looking for. So let's. Do I still have the calculator? I was doing something on the calculator. What was I doing? I guess we can just calculate beta here. So ChatGPT already gave me the formula, and then I would say this is worth memorizing. Beta is equal to square root of 1 minus 1 over gamma squared. Um, so so 1 over 22 squared and let me store that into memory. I'm afraid to just write down the significant figures, and maybe I need more, so I'm afraid to just manually type it. I stored it into memory, and let me now. There was a sorry. I'm Let me look at the history. Yeah, that was 1 over 22 squared, so I need to subtract this now from 1. So 1 memory minus? It does have? No. Oh, I might have done something wrong. Memory recall? Yeah, sorry. I need to uh, add 1. Okay. Memory store. That's 1 over gamma squared. That's the 1 minus memory recall. So that's the quantity under the square root. And I think when you take square root, this is going to get worse. So when you take the square root, then yeah, well, maybe not that much worse. I would want to put in this 9. So doing that, it's a 0.9969. But I think you can actually do 0.997. It should be graded as correct. Although they say, up to 10,000 place. So let's give it a try. 0.997. That's what my calculator said was the closest value. Here's the history. Oh wait, you can't really see it. Well, it's uh, 0.997, rounding this last 9. But I can even do this 69, and I'm pretty sure this won't be graded as correct. Let's give it a try. Although I need to make sure that it's not extended to 10,000th place. So let's do that. Then we get that, oh, it's wrong. And I think if I did a 69, it might now grade as correct. Let's see. Not yet. That's interesting. All right, let's make sure how close into the constraint I have to go. Um, yeah, one. So let's just solve for beta out of this equation here. So 1 minus 1 divided by 22 gamma squared. Okay, when you say equals, you get that. And when you take the square root, I guess I must have missed the digit before. It's 0.998996. So it's like 0.9991. So 0.99891. This should be graded as correct. So let's do it this way. I think, yeah, this is definitely substantive question. There are many mistakes I can make. I already got it to help. Oh, wait. Yeah, this is what happens when I'm falling asleep. When I was asking, this question asks for about beta. I didn't actually paste in the question. So let me paste in the question. And I'll do. Okay, this is the question I was working on earlier. Thank you for your help with the part A. For part B, it says um, there's some shortcut of a sort, so I don't need to use the value of C. I mean, you could use the value of C and just use all from alpha. That might be quicker, but it's meant to be kind of help you develop number sense, help you develop little nifty tricks and shortcuts. So the trick is, yeah, the definition of a light year. So if something's traveling at C, then it takes 9 years to get to 9 light years. So let's see. Yeah, yeah, that's it. So if it's at speed beta of fraction less than c, then you just take the reciprocal of it because the time is so what we are using is what you learned in physics 4a. The speed is distance per time or reversing relationships. What this means is time is equal to distance divided by speed. So you are dividing by speed and you divide by beta on the denominator only, thinking or yeah, denominator only thinking, expecting that c's will cancel out, but you still plug in beta. Um, so hence for star 9 light years away at this speed. It might be close enough. ChatGPT actually calculated 9.01 years. It might be this number here might be close enough to one that if I just plug in 9 years, it might say that's correct. Yeah, yeah, yeah. It didn't have a more stringent than 1% tolerance. I think it makes sense. Uh, all right. Um, I got it. The question, the systems also says just 9 years is correct. Uh, I'm guessing because the relativity, because the relativistic fraction is pretty small. Um, uh, I got it wrong for C though. Um, I took the proper time 9 years and then multiplied it by 20 to get 190, uh, 198, 198 years, but it says it's wrong. With the time dilation or length contraction, the biggest source of mistake is you put the gamma on the wrong side. That's why I teach you the phrase, moving rulers are short, moving clocks are slow. Then you can think through with each situation, what does it mean for a clock to be slow? That means, as you see the clock tick down a second, if you have another clock to use as reference, that reference clock would have counted way more than a second. So, let's say I need to paste this in so that ChatGPT has the info, and I'm hoping it'll guide me correctly to how to do this. So within astronauts reference, that's actually pretty involved. I think you have to find the length contracted distance of travel. 9 light years. Um, take the Lorentz vector first, uh, and then think it through. Should it be on the denominator or numerator? Uh, yeah, mix up. Yeah, yeah, that's definitely a mix up in how it's stated here. The 9 years is not the proper time; it's just the time measured by a observer moving relative to the spaceship. So yeah, travel electron, which time is direct. Yeah, right. The time is on their own clock. Is the shorter clock the time? Mathematically, what's a T of Earth? Uh, Not sure what it is. Doesn't help that I'm falling asleep. Um, time of Earth. Time measured from an observer on Earth, and gamma times t astronaut would be time measured by the astronaut. So yeah, t astronaut takes 0.41 years. Uh, years. So So let me ask you this follow question. Wow, is that right? That doesn't sound right. How does 9 years shrink? into 0.41 years. And I guess that this is in some senses, a somewhat terrible thing to say, in a physics class to tell you don't trust your intuition. But I do have to tell you that, especially as we go into special relativity and quantum mechanics, because our intuition will simply mislead you if we are thinking intuitively instead of somewhat rigorous approach using mathematics. That's one of the reasons I love this class so much, because there's no other class where you can teach this modern physics material at the level they ought to be. Because in physics 10, you can't use matrix multiplication, you can't use calculus, you can use a bunch of stuff. Let's see. It does sound surprising. Yeah, the consequences of relativity or plane. Yeah, the travel time of roughly 9 years from the distance divided by the speed. That'll give you distance. From astronaut to frame, however, the distance is contracted by the factor. Yeah, that was one of the paradoxes we considered earlier in the lecture. Since gamma is equal to 10 to oh yeah, it's pretty good. So it's filling out all the details on the other side are necessary. So because let's see, the distance as this, and that'll tie directly to the amount of speed of light. Um, so I'll answer 0.41, and let me ask this, because I can ask basically a version of the time dilation paradox question. So I'll say, all right. All right, I got the right answer, but it still makes no sense to me. So the Earth clock measures 9 years, and from the astronaut perspective, the Earth clock is moving, so it's slower. Uh, shouldn't that mean that the um it's a slower, meaning it it takes more than 9 years to measure 9 years slower. Shouldn't that mean that the um, astronaut clock uh, counts more hours to many more hours um, to the Earth clock of 9 years, not less? Let's see how ChatGPT answers it. Last year, it didn't do so well with the modern physics questions. Let's it's a you let's say you get an answer and you don't understand it. You want an explanation. ChatGPT can be great. Let's look at this particular explanation. Classic. Yeah. That really a lot of the paradoxes come down to this. Yeah. What's the brain? So it's really slow. Yeah. The resolution is that time dilation is real. Yeah, we use the word observe, which events at different locations at the same time. Yeah. This all of this is a lot easier to illustrate with the space-time diagram. Which did I do that in this way? I think I did introduce a space-time diagram. Let me just to check. um, um, I feel like I would have done it here, lecture 11. But I didn't do it here, and nope, didn't do it here. Then I could have done in lecture 10. If I didn't do it there, then it's coming up next week. It's possible I waited until Yeah, yeah, because I'm beginning to introduce and justifying the postulates. So it's gonna be there next week. So look for the space-time diagrams next week as you start to build competency and confidence with the special relativity problems. So from Earth's frame distance to the star, yeah, it takes 9 years from the astronaut to plane. Yeah, the important thing is the star and Earth are both moving. I don't know if that's right. I mean, I guess Earth is moving in from the astronaut brain. Um, you imagine there being like a length measuring thing from Earth to the distant star, and as you travel along that line, you would see length contraction. So I think that's what this is describing. From the astronaut's brain, um, the 다시 it's an Earth time at the moment of the show already. Yeah. So that is the correct word description. I don't know how well that makes sense to people. So let me end with this. My instructor recommends use of something called space-time diagram. Can you reformat your explanations here in terms of space-time diagrams? And it's possible that it can't quite do that. One, I'm pretty sure it can't draw the diagram. It has never been good at drawing technically correct diagram. And yeah, but it's describing. Let's see if the description is something detailed enough to follow. Let's just give that a try, and then we'll end this session here. Sorry. I really should have taken a nap between the two sessions so that I'm not so tired right now. The vertical t-axis is the Earth's time coordinate. Horizontal x-axis is the spatial coordinate. World lines. Earth is a straight line at vertical x equals 0. Okay, that's good. I might ask you to explain world lines because I'm just trying to follow it, but maybe follow it blindly without knowing what each word means. The star is a straight vertical line at x equals 9. So let's say this drawing is big enough to include both. Um, so let's say this is 9 years. And the world line of the star should look something like um, this. So Earth is a straight vertical line at x equals 0. Star is straight vertical line at x equals 9. That's probably fine. The amendment. The astronaut travels along a diagonal line. I don't know if that was part of the question, but let me ignore the last bullet. How Earth sees the ship. 9 years. Um, the space-time diagram. Like with astronaut frame. Um, Sorry, I'm having trouble reading it because I'm falling asleep. Uh, so I'll just end with one last question. Sorry, I tried following your descriptions to draw a picture for myself, but I must be too tired. I'm having difficulty doing it. Can you just give me the diagram you are using? and it'll probably say no. Whenever I try to get it to draw technical diagrams like free body diagram, it just either refused outright, or when it did attempt using some other model, it was lacking. Yeah, so I've seen it try to do ASCII sketch. That's how complete this ASCII sketch is. Earth frame. I still think it doesn't quite make sense, but part of it could be that I'm tired. Part of it could be that this drawing actually is incorrect. So I think that's sorry, that's all that I have energy for right now. Let me just make sure the last question we didn't see. Wait, that is the last question. So I think that's good. Sorry. I'll try to come in more rested next week's session so that I can be full of vigor for the session. So let me stop the. Let me say goodbye to people joining by recording the video. In case people who are here in real time have any questions, I'll stay online briefly. Sorry for the early end and kind of rambling, sleepy thing. Next before next week's session, I'll be sure to take a nap so that I come in more refreshed to this session. So bye to people joining by recording the video.